The universe opens like a silent, infinite film reel, dark, restless, and impossibly vast. In the beginning, there is only a slow drift through a cosmic ocean, the camera gliding past ancient starlight that has traveled billions of years just to be seen. Each photon feels like a whisper from a forgotten past, illuminating dust clouds that twist like spectral creatures frozen in time. Nebulae bloom in the distance, glowing with the soft fire of newborn stars, while galaxies spin in elegant spirals, unaware of the secrets they orbit around. Everything feels alive, humming with quiet energy, until the motion begins to slow, the color begins to fade, and the cosmic landscape gently collapses into nothingness. It happens gradually, like the dimming of a candle flame. One moment the universe is full, vibrant, expanding with radiant purpose, and then, without warning, the light dissolves. Stars vanish. Galaxies retreat. Space itself falls silent. It is as if the cosmos is holding its breath. At first, the emptiness seems ordinary, just another lonely stretch of intergalactic space. But then the camera keeps moving and the emptiness keeps growing. Darkness spreads beyond reason, swallowing everything around it until the viewer feels suspended inside a bottomless well. There are no galaxies drifting at the edge of perception. No scattered particles dancing in the void. Not even the faint glow of cosmic background radiation seems willing to enter this space. It is a silence so complete, so absolute, that it becomes unsettling. The kind of silence that suggests an absence not just of matter, but of truth. The feeling shifts from curiosity to unease. Space is supposed to be empty, but not like this. This emptiness carries weight, like a presence hiding behind the absence. Something in it feels intentional, deliberate, almost as if the universe is turning its face away, hiding a scar it doesn't want us to notice. As we drift deeper, the darkness begins to take on texture, not physical but emotional. A tension hums through the void, like the low vibration of an unseen engine. It feels ancient, heavy. A boundary between what we are meant to understand and what we were never supposed to see. In this strange silence, the viewer starts to feel watched. Not by a creature or entity, but by the universe itself, as though this place marks a forbidden chapter in its history. The darkness becomes a metaphor for everything humanity still cannot explain. The missing mass, the unseen forces, the grand mysteries tucked beneath the fabric of spacetime. This invisible place becomes a symbol of all the cosmic puzzles the universe tried to leave out of sight. And yet, here we are, floating toward the center of a nothingness so large it stretches the definition of emptiness itself. The camera pushes forward, deeper into this abyss, and time begins to feel distorted. Seconds stretch. The silence becomes thicker. Even distant stars, far outside the boundary of this void, seem to dim, as though their light is reluctant to cross into this region. A delicate fear settles in, an instinctive discomfort that humans have felt for millennia when staring into dark caves or endless oceans. But this is far more profound because this darkness is not natural. It feels engineered by the cosmos, carved into its structure like a secret vault. A faint vibration ripples through the scene, almost imperceptible. Then the tension rises again. It becomes clear that this is no ordinary region of space. This is a void so immense that it redefines cosmic scale. A hollow where the fabric of existence feels thinner, weaker, almost punctured. A place where the universe's voice drops to a whisper, as if warning us not to come closer. Yet the pull of the unknown is irresistible. Curiosity propels us deeper, past an unseen threshold that separates familiar cosmology from forbidden territory. Particles that normally drift freely through space seem to avoid this region, skirting around the edges like birds avoiding a storm. Light itself bends subtly, not from gravity but from something stranger, something that suggests the laws of physics behave differently here. The camera slows as the darkness thickens, forming a boundary so profound that it almost feels alive. Every instinct says to turn back. But instead we push forward, crossing into the heart of what should not exist. As the void envelopes us, the sense of scale becomes overwhelming. This is not an empty pocket of space. It is a chasm, a silent, cosmic riddle carved into the universe's blueprint. The deeper we go, the more the truth becomes undeniable. This region is not random. Its borders are too clean, its shape too deliberate. The emptiness becomes suspicious, as though crafted by an unknown force or shaped by a forgotten event. The silence presses in, heavy and suffocating. And then, just when the darkness feels infinite, something shifts. A subtle glimmer at the corner of perception, like a memory trying to surface. The universe may have tried to hide this place, burying it beneath billions of years of cosmic evolution. But its existence is undeniable, etched permanently into spacetime like a secret wound. Whatever lies at the center of this void feels ancient and powerful, waiting to be uncovered. The camera stops. The silence deepens. And the question lingers in the air, trembling with cosmic weight. What did the universe try so hard to hide here? The answer feels close, hovering just beyond reach, concealed by a darkness that was never meant to be disturbed. The universe has always been a master of illusion, offering us just enough light to study, just enough structure to map, just enough order to believe we understand it. But beneath that shimmering surface, beneath every star, nebula, and swirling galaxy, lies an architecture built on secrets. It is a cosmos that reveals itself in fragments, like a story told through scattered pages, each one hinting at a larger narrative we were never meant to fully grasp. As we drift through interstellar space, we begin to sense the quiet intentionality of the universe, the hidden corridors of dark matter threading invisibly between galaxies, the unseen gravitational hands shaping clusters, and the silent forces sculpting voids as if chiseling empty chambers into the body of reality. Everywhere we look, there is more hidden than revealed. Dark matter outweighs all visible matter, yet it remains a silent ghost. Dark energy drives the expansion of the universe, yet it refuses to show its face. Quantum fields ripple beneath existence, yet they remain intangible, unreachable. It is as though the universe has erected a veil, thin enough to tempt our curiosity, thick enough to guard its deeper truths. The cosmos behaves like an ancient architect who has built a cathedral of unimaginable scale, leaving behind visible pillars and arches but concealing the blueprints that explain why any of it exists. The deeper we study the cosmos, the more we realize how little we truly understand. Scientists map galaxies across billions of light-years, tracing luminous pathways like glowing veins across a cosmic body, but even these maps feel incomplete. They reveal the visible skeleton of the universe while hiding the hidden organs. The voids, the anomalies, the regions where the rules seem to falter. Each discovery opens a door only to reveal two more locked behind it, creating a labyrinth where every answer becomes another mystery. The more the universe grows in size before us, the more its silence feels deliberate, like it is guiding us toward some truths while diverting us from others. There are moments when this silence feels almost philosophical. Why does the cosmos show us only the surface of its story? Why surround everything with invisible forces, hidden matter, and unspoken laws? It is a question that leaves scientists torn between awe and suspicion. The universe could have been simple. Instead, it wrapped itself in layers upon layers of secrets. It formed a reality so intricate that even with our best instruments, we only glimpse its outer skin. And while that outer skin dazzles with supernovae, quasars, spiral galaxies, and glowing clouds of gas, it distracts from the deeper structures lurking beneath. Imagine drifting past stars burning with fierce brilliance, only to dive into corridors of darkness where invisible threads stretch like cosmic muscles holding galaxies in place. Picture looking at a galaxy cluster and realizing that the galaxies themselves are mere ornaments hanging on an unseen framework. The universe is not the glowing matter we see, it is the dark, silent scaffolding that surrounds it. And that scaffolding feels intentional, like an intricately engineered foundation holding up a structure far more mysterious than its visible decorations. As we go deeper into this conceptual maze, the contrast intensifies, the beauty of luminous space on one side, the unsettling invisibility of its true architecture on the other. It becomes clear that the cosmos is not just hiding small details, it may be hiding entire chapters of its own history. Ancient collisions, forgotten formations, ruptures in space-time, events so powerful they scarred the universe long before planets formed or starlight ever traveled these distances. These secrets lie dormant, buried under billions of years of cosmic expansion, waiting to be rediscovered. And then comes the most haunting realization of all. Perhaps the universe did not merely keep secrets unintentionally, perhaps it designed its own concealment. Perhaps its silence is a protective shell, guarding us from truths too vast, too strange, too destabilizing for a young species still struggling to understand gravity, time, and consciousness. The more we uncover, the more we sense the shadow of something deeper. A hidden order. A concealed pattern. A suggestion that the universe might know more about itself than it allows us to see. As we glide deeper into this grand mystery, the void reappears in our minds, the impossibly large emptiness that should not exist. And suddenly, all the universe's secrecy begins to form a chilling possibility. Maybe that void is not just an anomaly, but a clue the universe meant to bury. A secret it hoped we'd never uncover, hidden behind the illusions of light and matter. The cosmos may be built on secrets, but some secrets, it seems, were meant to stay in the dark. Astronomers have always been explorers of light, chasing every faint glow, every distant whisper of radiation, every fragile photon that manages to survive billions of years of cosmic travel. Their entire craft is built on reading the luminous fingerprints of the universe. So when they pointed their telescopes toward a particular region of the sky expecting to find the usual cosmic clutter, galaxies, dust, radiation, or at least the diffuse glow of leftover energy, they were met with something profoundly unsettling. They saw nothing. Not emptiness as in very little, not sparsity as in a few scattered galaxies, but a type of absence so absolute that it threatened every assumption they had about how the universe works. At first they suspected error. Instruments malfunction. Sensors drift. Data sometimes lies. But the readings were not just empty, they were consistent. Night after night, telescope after telescope, everything pointed toward the same impossible conclusion. A vast stretch of space where matter seemed to vanish. It was as if someone had taken an eraser to the cosmos and wiped the region clean. Astronomers stared at their screens, expecting patterns, noise, or even random interference, but instead they found a stillness so perfect it felt artificial. The instruments weren't misbehaving. The universe was. The silence of that region wasn't passive, it felt intentional. Normally, even the darkest pockets of space contain something. Rogue stars, drifting dust, stray gas particles, or at the very least the faint hum of cosmic microwave radiation left over from the Big Bang. But here, the usual cosmic background seemed muted, subdued, almost fearful of entering the space. It was like staring into the deep of an ocean trench where sunlight refuses to go. The kind of darkness that doesn't just exist, it dominates. Astronomers exchanged uneasy glances. They were trained to handle anomalies, but this one felt different. Some described the discovery as the quietest silence they had ever measured. Others noted that the absence appeared too uniform, too sharply defined, as though the universe had carved a hollow into its own body. And behind their scientific caution, a deeper emotion stirred, an instinctual discomfort that every human feels when confronted with a blankness that seems unnatural. The void radiated a kind of negative presence, like the cold draft from a hidden doorway. As deeper surveys were conducted, something even stranger emerged. The emptiness wasn't chaotic, it had structure. The few galaxies that did exist around the edges appeared to curve unnaturally, as if pushed aside by an invisible pressure. Some astronomers likened it to the way iron filings arrange themselves around a magnetic object that can't be seen. Others compared it to the wake left behind by a massive ship passing through water. But there was no ship, no mass, no gravitational source strong enough to carve such an enormous path through the universe. Nothing but absence shaping the world around it. The deeper they looked, the more contradictory the region became. In some wavelengths, the void appeared colder than the surrounding space. In others, it appeared disturbingly warm, as though it were emitting heat with no explanation. These irregularities did not follow known physics. They didn't even disagree with theory, they simply refused to fit into any theory at all. It was as if the void were operating under a different rulebook entirely. Scientists began to whisper. Some spoke cautiously about statistical anomalies. Others suggested unknown cosmic processes. A few, quietly and only among trusted colleagues, wondered whether this region might be a relic, something left behind by an event far more violent and ancient than the formation of galaxies. But none of these explanations accounted for the simplest, most unsettling truth. The void looked unnatural. The public wasn't informed at first. Not because of secrecy, but because astronomers didn't yet have words for what they were witnessing. They needed time to collect data, time to test instruments, time to convince themselves that the universe really contained a whole so large and so empty that it made known cosmic voids look like tiny imperfections. This one was different. Where most voids were scattered like bubbles in cosmic foam, this one stood alone, colossal and clean, as if carved intentionally. And then came the moment that pushed the scientific community from curiosity into genuine concern. A group of researchers compared early observations with newer ones and noticed something chilling. The void's boundaries weren't static. They seemed to shift, not dramatically but subtly, like the faint breathing of a sleeping giant. One team hesitated to publish, fearing ridicule. Another doubted their data entirely. But more teams confirmed the same disturbing signal. The void was not stable. It behaved less like a static absence and more like a dynamic region that interacted with the universe around it. For astronomers trained to see patterns, this was terrifying. Patterns meant intention. Patterns meant processes. Patterns meant something was happening inside the void, something they could not see. By now, the unease had become impossible to ignore. The question that hovered in every research meeting, in every published paper, in every sleepless night was simple but devastating. Was the void simply empty, or was it hiding something? And if it was hiding something, what force was powerful enough to conceal its presence across billions of light-years? The most experienced astronomers, those who had mapped galaxies, hunted quasars, measured the fabric of space-time, found themselves staring at the void like sailors staring at a silent storm on the horizon. Something ancient and enormous lay beyond that darkness. And for the first time, humanity realized that the universe doesn't just contain mysteries, it protects them. They expected the void to be large. After all, the cosmos is sprinkled with empty regions, bubbles and gaps formed by the uneven distribution of matter after the Big Bang. But nothing prepared them for what the data revealed next. When astronomers finally calculated the true scale of the void, the numbers shattered every expectation and left seasoned scientists staring at their screens in disbelief. The void wasn't just vast, it defied cosmology itself. It stretched across distances so immense that even light, traveling at the fastest speed allowed in the universe, would take billions of years to cross it. This was not an empty pocket of space. This was a violation. A cosmic impossibility. A discovery that, by all known laws, simply shouldn't exist. The deeper the research teams looked, the more absurd the void became. It wasn't merely larger than predicted, it was orders of magnitude larger. Its volume dwarfed anything previously documented, swallowing entire superclusters into its silent shadow. The maps showed a hollow so enormous it looked like a missing piece of the universe's skeleton, as if a giant hand had scooped out galaxies with meticulous precision. Every model that predicted the distribution of matter in the cosmos failed instantly. Statistical predictions, inflation patterns, density fluctuations. None of it could account for a void so colossal and so clean. It was like discovering a canyon carved into the fabric of reality itself, one that no natural process could explain. Scientists found themselves trapped between awe and terror. They rechecked their data again and again, convinced that some hidden error must be corrupting the results. They recalibrated instruments, replaced sensors, ran simulations, cross-referenced surveys, and even consulted rival teams in private. But every method, every tool, every independent group returned the same impossible picture. The void wasn't just big, it was fundamentally wrong. It behaved like a cosmic riddle placed deliberately beyond the reach of known physics. The universe, it seemed, was suddenly rewriting its own rules. For many researchers, this discovery marked the first time they truly felt fear. Not fear of danger, but fear of the unknown. To find an object that contradicts the architecture of the universe is to confront the possibility that our understanding of reality rests on incomplete or flawed foundations. The void wasn't just challenging theories, it was mocking them. It ignored every explanation thrown at it, sitting in the darkness like a silent witness to truths older than galaxies. Scientists who once spoke confidently about cosmic evolution now whispered in hallways, wondering whether they had stumbled upon evidence of something ancient and unimaginable. One group proposed that the void might be the aftermath of a primordial event, something violent enough to evacuate matter on a scale beyond comprehension. But there was no signature, no trace, no residue. It was a perfectly clean emptiness, an absence without scars. Another group suggested that an unknown force might have pushed matter away, but the pattern of the surrounding galaxies didn't match gravitational repulsion or known forms of dark energy. Others speculated about exotic physics, hidden dimensions, or even relics of pre-universe conditions, but these ideas felt more like desperate attempts to explain the unexplainable. The truth was simple and unsettling. The void behaved like something placed intentionally, as though the universe carried a memory of an event it refused to reveal. The researchers began comparing notes from different wavelengths, infrared, radio, microwave, gamma, and found additional anomalies. In some frequencies, the void seemed colder than expected. In others, it produced faint signals that should not have existed at all. These contradictory readings deepened the mystery, suggesting that the void was more than empty space. It was a phenomenon, a presence hiding in absence. Public announcements were cautious, carefully worded to avoid panic or sensationalism. They described the void as unusually large or unexpectedly empty, careful not to reveal the true scale of the anomaly. Behind closed doors, however, the tone was different. Government agencies, space observatories, and academic institutions began forming quiet collaborations to understand what this thing was and where it came from. No one admitted it out loud, but the question hung heavily in the air. If the void should not exist, then what force created it? The void quickly became more than a scientific curiosity, it became a threat to the narrative of the universe itself. Every major cosmological model had been built on the assumption that the universe was predictable, understandable, structured by rules we could uncover with enough time and intelligence. But the void was a breach in that logic. A reminder that the cosmos is older, stranger, and far more complex than our theories allow. It was a whisper from the dark saying that the universe still held secrets too vast for human comprehension. And just when scientists thought the discovery had reached its peak of impossibility, new data came in. Data showing that the void was not merely a hole in space but perhaps a window. A disturbance. A region where the fabric of spacetime appeared subtly twisted, as if something once collided with our universe and left behind an echo vast enough to swallow galaxies. The implications were staggering. If the void was a relic of an ancient collision, then the universe may have a hidden past, one that predates everything we know. The realization hit like a cold shock. This wasn't just a discovery that shouldn't exist. It was a discovery that could rewrite everything we believe about reality itself. And in the center of that silent abyss, waiting beyond our instruments and theories, lay the one question no one wanted to ask. What happened here? It began as a simple metaphor, a void, a gap, an empty place in the cosmos. But the more astronomers studied the anomaly, the more it stopped looking like an absence and started looking like a wound. When they mapped its edges, the shape wasn't random. It wasn't the natural, uneven bubble one would expect from cosmic evolution. Instead, its contours appeared disturbingly smooth, almost sculpted, as though something had dragged through the universe and left a vast rupture in its wake. The void had the eerie symmetry of trauma. It did not look formed. It looked inflicted. As telescopes traced the perimeter, a faint distortion in spacetime itself slowly came into focus. Light bending at the edges, gravitational fields warping in subtle, unnatural patterns. These were not the signatures of random emptiness. They were scars, the kind left behind by immense forces strong enough to warp the universe's fabric like a bruise left on skin. Scientists described it reluctantly, but the comparison was unavoidable. The void resembled a cosmic scar. A mark where something catastrophic once pressed itself into reality, stretching the laws of physics until they nearly tore. It was the kind of distortion that should have left evidence. Debris fields, radiation signatures, lingering gravitational ripples. But there was nothing. No trace of collision. No chemical residue. No echo of an explosion. It was as if the wound had been cauterized perfectly, leaving behind only a clean absence. The universe had healed over, but the scar remained, silent and incomprehensible. The lack of remnants was more terrifying than the presence of any debris could have been. It suggested a force capable not only of carving into spacetime but of erasing its own fingerprints afterward. When researchers began running simulations, the results only deepened their unease. Natural cosmic processes couldn't recreate the precision of the void's boundary. Gravitational collapse didn't fit. Expansion models didn't fit. Energy fluctuations didn't fit. Even exotic theories, dark flow disruptions, early inflation anomalies, or quantum tunneling events, failed to match the data. It was as if the void belonged to a category of events not listed anywhere in the universe's rulebook. An intrusion, not an evolution. A trauma, not a structure. Some theorists proposed that perhaps the void was the aftermath of a violent expulsion of matter, like a cosmic explosion so powerful that it blasted galaxies outward, leaving nothing behind. But galaxies around the void weren't moving away as if fleeing a blast. They were arranged as though pushed aside by something enormous passing through. Others noticed that the alignment of the surrounding structures curved in a way reminiscent of a wake, a trail carved by a massive traveler through a medium. But in the cosmos, nothing is known to travel like that, nothing capable of creating such a furrow through reality without leaving chaos in its path. Yet the region around the void was calm. Too calm. The undisturbed serenity of the surrounding cosmos made the scar even stranger. It was like discovering a deep gash across the surface of an ancient stone while the rest of the monument remained perfectly intact. This paradox fueled even wilder speculation. What if the event that created the void didn't originate within our universe at all? What if the scar was the mark of something passing through from somewhere else? In private discussions, some physicists ventured a frightening hypothesis, that the void might be the remnant of a collision between our universe and another, a scrape across the boundary of reality from a time before matter settled and galaxies formed. In such a scenario, the scar wouldn't just mark a region of emptiness but a moment of contact. A moment where two universes brushed against one another like tectonic plates grinding in the dark. But if that were true, if the void was a relic of an interuniversal collision, then it wasn't simply a scar. It was evidence. Others rejected this idea not because it lacked logic, but because its implications were too vast, too destabilizing. A scar suggests a history, and a history suggests an origin, and the universe having a history before the Big Bang was a concept that threatened to upend everything. The void became less of a scientific puzzle and more of an existential threat, hinting at a cosmic timeline far older and stranger than humanity had ever imagined. As instruments improved and more detailed data arrived, one pattern became impossible to ignore: the void did not behave like an empty region. Its gravitational influence was subtly inconsistent, its temperature readings fluctuated with no apparent cause, and the radiation passing near its boundary bent in ways that seemed almost unnatural. It was as if the void had depth, not physical depth but narrative depth. A story buried beneath layers of time and silence, a story the universe had tried to seal away. The more scientists stared at the scar, the more it stared back. Not literally but emotionally. There was something haunting about the way it sat in the cosmos, a perfect wound with no attacker, no weapon, no witness. It felt like a reminder that the universe holds memories of events violent enough to scar spacetime yet mysterious enough to erase their own origins. And as the void's secrets deepened, one truth became unavoidable: scars don't appear without cause. Something happened here. Something powerful enough to reshape the fabric of reality. Something the universe tried very hard to hide. The deeper astronomers pushed their instruments toward the void, the more they realized that silence was not just an absence of sound, it was an active force. When they aimed radio telescopes into the region, they expected to detect the familiar cosmic static, the faint hiss of microwaves left over from the Big Bang, or at least the distant chatter of galaxies echoing across time. Instead they found nothing. A smooth, chilling absence. The signal didn't weaken. It didn't fade out gradually. It dropped off abruptly, like stepping from a brightly lit room into a sealed chamber of darkness. It was the kind of silence that felt engineered, as though the void was swallowing every signal that tried to cross its borders. Some described the experience as listening to the universe breathe, then suddenly realizing it had stopped. The first scientists to process the data felt something primal stir inside them. It was unnatural for the cosmos to be this quiet. Even the darkest regions of space emit tiny fluctuations, thermal whispers, quantum static. But the void seemed to devour these whispers, allowing nothing to echo back. It was as if sound itself refused to exist there, as though the emptiness had claimed ownership over every form of vibration. Researchers replayed the recordings again and again, hoping that some overlooked anomaly would break the silence. But every replay produced the same haunting void, an audio abyss as deep as the spatial one. To make sense of this eerie silence, astronomers began comparing signals from different wavelengths. They tried radio frequencies, microwave scans, infrared sweeps, optical measurements, gamma-ray detectors, every tool available to modern science. Many regions of space reveal themselves in one wavelength if not another, but the void resisted all attempts at illumination. It was a darkness that lived across the spectrum, a universal silence that refused to budge even when probed by the most sensitive instruments humanity had ever built. The deeper scientists ventured, the more disturbing the silence became. At certain frequencies they noticed something even stranger than emptiness: a complete flattening of data. Not randomness. Not noise. Just pure, uniform quiet, as though the sensors had been turned off even though they hadn't. This kind of uniformity didn't match any known natural process. Natural silence still has texture, slight fluctuations, thermal drift, statistical noise. But the void silence was smooth, perfect, absolute. Too perfect. It was as if the void wasn't ignoring signals. It was absorbing them. And in that thought, a new fear began to grow. Researchers began speaking in hushed tones about a possibility no one wanted to entertain. What if the void wasn't empty at all? What if something inside it was dampening the universe's voice, smothering waves of energy, muting the cosmos as though hiding behind a soundproof wall? Normally, waves reflect, scatter, or refract when encountering matter. But here they vanished completely. That kind of disappearance suggested a mechanism, something that acted deliberately or at least functioned with precise efficiency. One astrophysicist compared the void to a dead ocean, an expanse where no wind, no waves, no currents existed. Another likened it to entering a vast cathedral built from darkness, where the slightest whisper is swallowed by unseen walls. The analogies varied, but the feeling was the same. The void did not allow the universe to speak. And in that silence, something ancient seemed to linger. As observation teams refined their instruments, faint irregularities began to appear, tiny distortions at the boundary of the void. At first they were dismissed as glitches. But as they accumulated, the pattern became undeniable. Certain signals flickered at the edges as if interacting with a barrier. The signals would weaken, bend, and sometimes disappear altogether, almost as if a membrane of compressed space were absorbing their energy. This discovery sent a wave of shock through the scientific community. The void was not just a gap between galaxies. It had structure, an invisible shell of warped spacetime that acted like a sponge for electromagnetic radiation. No natural cosmic void had ever exhibited anything comparable. Instead of empty space, this region behaved more like a region of interference, a place where the universe's fundamental signals died unnaturally. Most chilling of all, the silence seemed purposeful. Not intelligent necessarily, but active, a phenomenon with behavior, not just existence. As the data grew more conclusive, a philosophical unease settled over the teams. Humanity had always assumed that space, despite its vastness, was transparent to information. Light travels, radiation spreads, energy echoes across the void. But here was a place where that rule broke. A place where information went to die. A place that erased evidence, erased signals, erased the universe's own voice. This raised questions that no scientific model could comfortably answer. If the void erased signals coming in, what happened to signals attempting to pass out? Could anything inside this region communicate with the rest of the universe? More disturbingly, was something already communicating and we simply couldn't hear it? One late-night research session revealed a detail so subtle that it almost went unnoticed. When they adjusted sensors to extreme sensitivity, they detected microscopic oscillations at the edge of the void. These oscillations were faint, almost inaudible, but they were consistent. They didn't match cosmic background noise. They didn't match known stellar activity. They didn't match any standard emission pattern. They were something else, something that danced on the boundary, flickering like a whisper caught in the wind. But these signals weren't coming from inside the void. They were coming from the barrier. Tiny, rhythmic pulses, like a heartbeat muffled behind a thick wall. Upon discovering the pulses, researchers debated endlessly. Some suggested it might be the universe responding to the void's gravitational anomaly, a kind of spacetime resonance. Others believed the pulses might be relic vibrations from whatever event created the void in the first place, a fading memory echoing through the fabric of reality. But the most unsettling interpretation came from a small group of theorists who dared to voice what everyone else feared. Perhaps the silence itself was a message. Not in words or symbols, but in the absence of information. A kind of cosmic warning encoded in emptiness. A signal that says, do not enter. Because to discover a region that erases signals is to discover a region that erases evidence. And a region that erases evidence may be hiding something. As researchers stared across the vast gulf of the void, into a darkness so pure it swallowed the universe's own radiation, they felt the weight of a terrifying question forming. What if something in the void does not want to be found? The silence was no longer just an absence. It was a presence. A quiet, patient presence waiting behind the boundary of nothingness, watching the universe from the depths of its own isolated darkness. The moment the void began defying every established model, the scientific world erupted into a quiet, frantic war of ideas. Theories collided like galaxies, brilliant, chaotic, and often destructive. Every cosmologist, physicist, and theorist who encountered the data felt compelled to explain it, even if that meant tearing apart the very foundations of modern physics. And so began the battle of theories, a clash that unfolded not in laboratories or observatories, but in midnight emails, fiercely debated conference calls, and whispered conversations in dim lecture halls where even the boldest minds hesitated to speak too loudly. The first wave of explanations came from traditional cosmology. Many tried to fit the void into known patterns, statistical anomalies, density fluctuations, remnants of inflation. But as the data sharpened, these attempts fell like fragile scaffolding collapsing under their own weight. Ordinary voids were irregular, scattered, chaotic. This void was a symmetrical abyss, a calculated emptiness stretching beyond prediction. Each simulation that tried to recreate its shape failed spectacularly, like trying to sculpt a perfect sphere out of melting wax. Then came the inflation theorists who suggested that perhaps the void was formed during the universe's earliest expansion, a region where quantum fluctuations had stretched abnormally far apart. But for such a massive anomaly to exist, inflation would have needed to fluctuate on unimaginable scales. The equations didn't survive scrutiny. The inflation hypothesis crumbled. The data pushed back with cold indifference. Next emerged the multiverse theorists. They proposed that the void was evidence of something even more dramatic, a collision between our universe and another in the early moments after the Big Bang. Two expanding bubbles of spacetime brushing against one another like celestial tides. This idea electrified the community, not because it was proven, but because it carried the unmistakable scent of forbidden knowledge. If true, the void wouldn't simply be a structure, it would be a scar left by an ancient interuniversal impact. But even this explanation faltered when confronted with the precision of the void's emptiness. The boundaries were too clean. The center too silent. It was as though something had not collided but carved. Meanwhile, dark flow theorists entered the fray with their bold claims. They believed the void might be connected to the strange motion of galaxy clusters drifting in one direction, almost as if pulled by a massive, unseen structure outside the observable universe. Could the void be an exit wound of sorts? A portal-like region, its gravitational influence tugging at the cosmic web? But measurements around the void showed no such directional pull. Whatever the void was, it didn't behave like a gateway. It behaved like a barrier. Quantum cosmologists were next. They proposed exotic interpretations involving vacuum decay, quantum tunneling, or regions where the Higgs field behaved differently. Their models drew diagrams filled with impossible shapes, energy states collapsing like dominoes, regions where reality itself thinned to a membrane. These ideas were thrilling but terrifying. If the void were a region of failed vacuum stability, then even approaching its boundary might one day trigger catastrophic consequences. But even here, the data refused to cooperate. No decay signatures. No energy imbalance. No radiation burst. The void was quiet. Too quiet for something so supposedly unstable. At the fringes of academia, bolder theories began to surface. Ideas that mainstream scientists dismissed publicly but whispered about privately. Some speculated that the void might be a region where the universe lost contact with itself, a zone of fractured spacetime where information could not survive. Others hinted that the void might be artificial, or at least structured by an unknown mechanism. They avoided the word engineered, but it hung unspoken in every debate like a shadow no one wanted to step into. The battle intensified as each new telescope, each new simulation, each new measurement tore apart another explanation. It became increasingly clear that no existing theory could fully describe the void. Instead of narrowing down possibilities, data seemed to widen the abyss of uncertainty, pushing the scientific community to the edge of intellectual panic. Every discovery raised more questions. Every answer collapsed into contradiction. What disturbed the community most was how the void seemed to challenge the principle of cosmic uniformity, the idea that the universe, on large scales, looks the same everywhere. This principle was sacred to cosmology, the bedrock of every major model from the Big Bang to the cosmic web. But the void violated it without remorse. If one region of the universe could be this impossibly empty, what else might be hiding across the cosmic map? Was the universe truly predictable, or had humanity simply been looking in the wrong places? Arguments turned heated. Careers trembled. Entire departments split into factions. Some scientists clung tightly to established theories, desperate to preserve the order they had spent decades building. Others embraced the chaos, excited by the prospect that the universe was stranger than anyone dared believe. The tension became palpable in academic circles, an invisible pressure, not unlike the eerie force surrounding the void itself. Yet through all the noise, one unsettling truth began to resonate across all theories. The void was not a mistake. Not an accident. Not a glitch in the fabric of the cosmos. It was deliberate in its silence, intentional in its geometry, precise in its shape. It behaved less like a natural phenomenon and more like the signature of an event that refused classification. And then, almost reluctantly, the scientific community found itself asking the question that had been hiding beneath the surface since the first data arrived. If none of our theories explain the void, what does? The battle of theories no longer felt like science. It felt like the universe was daring us to look deeper, and warning us that the answers would change everything. From the moment the void's impossible size and unnatural symmetry came to light, one theory lingered like a ghost, dismissed at first, whispered later, then finally spoken aloud in late-night meetings where even veteran scientists felt the weight of their own daring. What if the void wasn't created by something inside our universe, but by something that came from outside it? What if the great wound carved into spacetime was the leftover imprint of another universe brushing against our own in the earliest moments of existence? The idea was radical, terrifying, exhilarating. It suggested that our universe was not alone. That beyond the limits of our cosmic horizon, beyond all we can see or measure, another realm of physics once collided with ours like two vast, expanding waves in an endless sea. The imagery alone was overwhelming. Two primordial universes, immense and newborn, drifting through a higher dimensional landscape, their boundaries inflating outward until they finally touched. And in that moment of contact, reality would have shuddered. Proponents of this theory imagined the collision like two colossal spheres pressing against each other. The boundary between them would warp, compress, and twist. Shockwaves of energy would ripple across both universes. The fabric of spacetime would distort like molten glass being pushed inward. The result? A scar. A bruise. A disturbance so large and so ancient it could stretch across billions of light years, long after the universes involved had cooled, evolved, and forgotten the event. To the researchers exploring this idea, the void looked like such a bruise. It had the unmistakable features of an impact zone, symmetrical edges, a compressed center, and a gravitational fingerprint that behaved like a region pressed inward by an unimaginable force. It wasn't a chaotic emptiness, it was a clean indentation, as if something had pressed into the universe and then retreated, leaving behind a perfect hollow. The more they studied the maps, the more the void resembled the aftermath of two cosmic membranes colliding in the dark. Yet the implications of such a theory were monumental. It meant the Big Bang was not the beginning but a continuation, a chapter in a far older story written across realities stacked like layers of a cosmic tapestry. It suggested that the universe had siblings, that we might be one bubble among a vast, unseen foam of universes expanding through an incomprehensible metaspace. And if universes could collide, then they could leave behind bruises, scars, and voids, silent monuments to impossible encounters. Some simulations supported the idea disturbingly well. When researchers modeled early universe collisions, the result was a massive zone of lower density, an area where matter thinned out dramatically, forming shapes eerily similar to the void we observe. These void-like scars persisted through cosmic evolution, carried forward by expansion just as a bruise stretches as skin is pulled. The simulations produced temperature imprints too, a cold region in the cosmic microwave background that matched the mysterious cold spot already puzzling cosmologists. It was as though the universe itself had left behind a faded fingerprint of an interuniversal collision. But not everyone was convinced. Critics argued that if a collision occurred, the effects should be far more chaotic. Twisted matter streams, violent distortions, catastrophic waves of energy. Yet this void was serenely empty, clean, quiet. Too quiet. Too perfect. It lacked the messy signature of a violent event. This paradox created a deep divide. Was the void the result of an ancient collision smoothed out over billions of years, or was it something even stranger? Supporters of the collision theory countered with a haunting thought. What if the universe had actively healed the wound? Just as biological tissue smooths over a scar, cosmic inflation in the early universe could have stretched and softened the impact's aftermath, leaving behind a massive but eerily clean imprint. The universe may have covered the wound but not erased it. The void, then, would be the last whisper of a violence too ancient for memory, too immense for comprehension. Even more unsettling was what this implied about the other universe. If it collided with ours, what became of it? Did it retreat back into the metaspace beyond our perception? Did it continue expanding beside us like a shadow realm? Or, impossibly, could it still be touching ours at various points, leaving behind additional scars we have yet to notice? Some theorists wondered if the void might not be the result of a single collision but part of a larger pattern. Evidence that our universe had interacted with others multiple times. Perhaps what we call voids are not mere empty regions but ancient bruises from countless encounters. If so, then every massive void scattered across the cosmos might be a page from a story of collisions written not in matter but in absence. As the idea gained traction, the tone of scientific discussion shifted from academic to existential. If universes could collide, what else could they do? Exchange matter? Exchange energy? Exchange information? Could something from the other universe have leaked into ours during the impact? Could something be left behind in the void? These questions became more than scientific speculation. They became a source of deep philosophical unease. The void was no longer just an anomaly. It was a clue to a hidden cosmic history. A history that the universe itself might have tried to bury under billions of years of expansion and silence. But the most unsettling possibility wasn't that another universe collided with ours. It was that the collision wasn't accidental. That the bruise was deliberate. That the void might not only be a scar, but a doorway opened for a moment in the distant past, a passage from another realm that briefly touched our reality, and then closed, leaving behind a hollow signature in spacetime. Whatever pressed against our universe, whatever brushed against it long before stars existed, may have left more than a bruise. It may have left a question. A question so enormous it echoes through the void even now. What exactly touched our universe, and why does its imprint still remain? When the void was first mapped, it was terrifying enough on its own, an empty scar carved into the universe. But then researchers turned their attention to another cosmic anomaly, one that had been puzzling scientists for years: the cold spot. A massive, unusually cold region imprinted on the cosmic microwave background radiation, the ancient afterglow left behind by the Big Bang. It was a faint bruise on the universe's earliest light, a mysterious patch that defied statistical expectation. At first, astronomers dismissed it as a random fluctuation, an oddity with no deeper meaning. But once the void was discovered, everything changed. Suddenly that cold region looked less like an accident, and more like a clue. The cold spot was enormous, spanning nearly 1 billion light-years across the sky, far too large and too cold to be explained by ordinary cosmic variance. It was as if the universe had cooled unevenly in that specific direction, leaving behind a faint thermal shadow. When scientists compared its location with large-scale maps of the cosmos, the connection was immediate and chilling. The void sat directly in front of the cold spot. The alignment was too precise, too perfect, too intentional, looking to ignore. It was as though the void and the cold spot were two sides of the same wound, one carved into space, the other imprinted onto time. As researchers studied the cold spot more closely, they noticed something unsettling. The temperature drop wasn't uniform. At the center, it plunged sharply, colder than any surrounding region. But at the edges, it seemed to ripple outward, like a bruise spreading across the surface of an ancient body. This pattern didn't match the predictions of cosmic inflation theory. Nor did it match ordinary gravitational cooling. Instead, it looked like something had pressed into the early universe from behind, leaving a thermal dent, one that the laws of physics begrudgingly preserved over billions of years. The mystery deepened when cosmologists attempted to recreate the cold spot using advanced simulations. They tried modeling it as a line-of-sight effect from passing through a large void, known as the integrated Sachs-Wolf effect. Light traveling through an underdense region should lose energy, cooling slightly. But even when they simulated a void larger than anything known, the temperature drop still didn't match what we observed. The cold spot remained far too cold, far too deep, far too distinct. It was as if the void didn't simply distort the light passing through it, it imprinted something onto that light. Some theorists began whispering comparisons to fingerprints, thermal fingerprints left behind by ancient cosmic events. Others suggested the cold spot might be the residue of a burst of exotic energy, something that had once pressed against our reality with such force that its thermal echo could still be seen today. But the most provocative idea came from those studying multiverse collision models. The cold spot might be the visible memory of another universe's contact with ours. A scar left on the cosmic background when two realities brushed together like tectonic plates in the deep dark. The more scientists analyzed the cold spot, the more its shape mirrored that of the void. Both had eerily smooth boundaries. Both had central regions of extreme emptiness or extreme cold. Both defied statistical probability. And both seemed to align in exactly the same direction in the sky, as if pointing toward a hidden event that the universe itself had tried to bury beneath billions of years of expansion. As the data accumulated, some scientists grew uneasy. The cold spot wasn't just anomalous, it was accusatory. It seemed to ask a silent question: what happened here? Why is this region colder than the rest of the cosmic background? Why does it line up with a void that shouldn't exist? Why does the universe appear to carry a scar across its earliest light? These questions pushed researchers into philosophical territory. If the cold spot truly was a fingerprint of another universe colliding with ours, then the void itself might be the impact crater, the hollow aftermath of that cosmic encounter. The cold spot would be the thermal shadow of that collision, an imprint left on the universe when it was still young, still molten, still forming the seeds of matter and energy. One particularly unsettling hypothesis suggested that the cold spot might not be a simple imprint but a warning, an encoded memory of something violent enough to shake the structure of spacetime. If universes could collide, then the cold spot could be the leftover glow of a catastrophic event. And if such an event happened once, could it happen again? Not all researchers agreed. Some argued that the cold spot might still be a rare but natural fluctuation. Others insisted that our understanding of void physics was incomplete. Yet the alignment between the void and the cold spot remained undeniable. Every new piece of data made the coincidence harder to dismiss. The two anomalies behaved like twin signatures left by a single event. One carved into the universe's structure, the other burned into its ancient light. Late in the investigation, a new detail emerged that shook even the skeptics. When scientists measured the polarization of the cold spot's light, they found subtle patterns, tiny twists in the direction of the radiation's electric field. These twists didn't match known cosmic processes. Instead, they resembled distortions caused by a gravitational wave passing through the universe's early plasma. A wave strong enough to leave behind a permanent mark. A wave strong enough to come from a collision. Or from something passing through. Whatever created the cold spot did not merely cool the universe. It left fingerprints. Patterns. Distortions. Evidence of an ancient disturbance so large that its echo is still visible across the sky. And as scientists stared at those patterns, a realization began to form, not spoken publicly, not printed in journals, but whispered in quiet rooms. If the cold spot is a fingerprint, what exactly left its mark on the early universe? The void and the cold spot were no longer separate mysteries. They were parts of the same story. A story that the universe had tried and failed to fully hide. In the beginning, the void looked like a simple absence, a dark patch on a cosmic map, a region so empty it defied belief. But as astronomers refined their surveys, improved their instruments, and stitched together deeper and deeper slices of the universe, something remarkable began to happen. The void stopped appearing as a vague emptiness and started revealing a shape, a structure. A presence defined not by what was there but by what wasn't. With every new data layer, infrared maps, radio contours, gravitational tracings, the void sharpened like a colossal silhouette emerging from the haze. And the more clearly it came into focus, the more unsettling it became. The first detailed maps looked innocent enough. A hollow sphere of space surrounded by galaxies clustered along its borders like grains of sand pressed against the edge of an invisible bowl. But as resolution increased, the contours of the void shifted from natural randomness into something disturbingly intentional. Unlike ordinary cosmic voids which appear lumpy and chaotic, this one had edges that curved smoothly, symmetrically, cleanly. It was as though the universe had carved out a perfect cavity using a tool no one could comprehend. Teams across the globe began to overlay different data sets, galaxy density maps over temperature fields, gravitational lensing scans over dark matter distributions. And with each new combination, the structure of the void became clearer. Its boundary wasn't a vague transition into emptiness. It was a sharp line, a sudden drop, a cliff in the cosmic landscape. The cosmos doesn't normally produce perfect transitions. But this region behaved like a bubble blown into the universe's fabric, its edges crisp and unwavering, its symmetry too precise to be accidental. The more they mapped the void, the more it resembled a cavity created by pressure, like something had pressed outward or inward with immense force, displacing matter uniformly in every direction. Researchers compared its shape to the imprint of a sphere pressed against soft clay, but clay eventually deforms irregularly, fracturing or sagging. The void didn't. It held its form across billions of light years, a hollow as geometrically pure as a mathematical construct. Gravitational lensing data added even more complexity. When scientists measured how distant light bent around the void, they discovered patterns that shouldn't have been possible. Light deflected along its border in concentrated arcs, as though the void had a thin shell of denser space surrounding a hollow interior. This shell distorted passing photons with eerie consistency, warping them in a way that resembled a lens crafted with purpose rather than a naturally occurring feature. This was when the term boundary began replacing edge in conversations, because edges are natural, but boundaries imply separation. As simulations improved, the void began revealing an even stranger secret. Its interior wasn't truly empty. It wasn't filled with galaxies or gas but with something subtler, a weakness, a thinning. A region where spacetime itself seemed stretched thinner than in surrounding space. The models suggested that inside the void, the density of dark matter approached near zero levels. It wasn't just missing matter, it was missing the very scaffolding of the cosmos, the invisible framework that binds galaxies and clusters together. The void was a cavity not only in matter, but in the universe's foundation. Then came the most troubling discovery: the shape of the void subtly changed depending on the wavelength used to measure it. Not dramatically, just enough that it couldn't be dismissed as error. In optical wavelengths, it looked perfectly spherical. In microwave readings, it appeared slightly elongated. In radio scans, faint asymmetries emerged, like the imprint of a hidden geometry trying to break through the illusion of smoothness. This multi-wavelength inconsistency implied that the void interacted with different types of light differently, almost as if the void had layers, nested shells of altered spacetime that revealed themselves only to specific frequencies. This was unprecedented. Void mapping had never produced anything like it. As cartographers of the cosmos refined their maps, the void began to resemble less a natural emptiness and more a structure, an architecture of absence shaped by forces unknown. It had thickness, texture, variation. In some regions, the void's boundaries bulged outward slightly as though pushed from within. In others, the walls seemed pulled inward, like gravity was competing with an unseen force. These patterns formed subtle ridges and grooves along the edge, too consistent to be noise, too patterned to be coincidence. And then came the discovery that changed everything. When researchers layered time-evolved simulations over the observational data, they found that the void's geometry didn't entirely match the typical evolution of cosmic structures. Instead of expanding uniformly with the rest of the cosmos, parts of the void appeared to resist that expansion. Certain regions seemed anchored, held in place by forces unaccounted for in any standard model. As if the void had a skeleton, an invisible architecture holding it together, even as billions of years passed. Some theorists whispered a possibility too unsettling to publish openly. The void might be a relic of a higher dimensional event. A deformation in our three-dimensional cosmic fabric created by something pressing on it from outside our spacetime. In that view, the void wasn't an empty region, it was a dent. A pocket. A weakened fold. A place where the universe had thinned after touching something beyond itself. Mapping the abyss became less about charting emptiness and more about tracing a wound. A hollow shaped with purpose. A cavity defined with mathematical precision. A boundary that behaved like the shadow of something massive that once intruded upon our reality and then withdrew, leaving only geometry as evidence. As researchers stared at the completed maps, multi-layered, color-coded, marked by gravitational contours, one detail stood out above all others. The void's symmetry was too immaculate. Nature doesn't make perfect shapes. But something did. And the void, now fully mapped, seemed to whisper one question louder than all others. What sculpted this colossal hollow into the heart of the universe? For a void to have such structure, such symmetry, such stubborn persistence across billions of years, something must have shaped it. Something the universe never intended for us to find. As scientists pushed deeper into the void's mysteries, mapping its shape, dissecting its silence, tracing the scars in spacetime, another group stepped into the conversation: philosophers. Not the quiet, abstract thinkers of dusty libraries, but those who specialized in the intersection of cosmology, consciousness, and the nature of existence itself. They entered cautiously, aware that the scientific world had no patience for speculation. But the void demanded more than equations. It demanded interpretation, meaning, context. Something ancient and unsettling stirred beneath its silence, and the scientists could analyze it only so far. For centuries, philosophers have wrestled with the concept of nothingness. To them, nothing is never simple. It is not the absence of objects, not the lack of matter, not even emptiness. Nothingness is a presence in its own right, a psychological force, a philosophical abyss, a question disguised as a vacuum. And when they looked at the void, they saw something profoundly familiar. They saw a physical manifestation of humanity's oldest fear, that the universe is not built on stable foundations, but on shifting shadows and hidden truths. The philosophers began by asking a dangerous question. Why does emptiness exist at all? In nature, emptiness is rare. Forests fill themselves with trees. Oceans fill with currents. Ecosystems fill with life. Space should do the same. Yet here was a region so violently empty it broke the rhythm of existence. Some philosophers argued that the void might represent a natural counterbalance, a cosmic reminder that absence is just as fundamental as presence. But others felt something deeper, something darker. They believed the void was not simply empty. It was intentionally empty, shaped to be empty, preserved in its emptiness by forces we do not understand. Ancient texts from Greek, Hindu, and Taoist traditions described the void, the primordial nothing that existed before creation. The abyss, the great emptiness, the silent foundation. Mythologies across the world spoke of regions that existed before the universe took form, places of infinite quiet where even the gods feared to look. To philosophers, the cosmic void echoed these myths, not in a literal sense but in the emotions it stirred. A sense of touching something primordial. A silence older than creation. A space untouched by the stories matter normally tells. As scientists studied the void through mathematics, philosophers studied it through meaning. They asked why the universe would contain a region so perfectly empty yet so structurally strange. They suggested that the void might hold lessons about creation, not by what it contains but by what it refuses to hold. One philosopher described the void as the universe's confession, a place where the cosmos reveals that it is not infinite in wisdom or intention, but stitched together by mysteries even it cannot erase. These ideas collided with scientific thinking in fascinating ways. Physicists argued that the void might be the result of cosmic inflation or inter-universe collisions. Philosophers countered that perhaps scientific language was too small for the void. That the void wasn't just a cosmological anomaly, it was an invitation to confront the unknown. A reminder that humanity's understanding of existence is still painfully limited. A challenge written into space-time itself. Some philosophers proposed that the void might act as a cosmic mirror. Not a literal one, but a metaphorical reflection of human fear and curiosity. When humans stare into darkness, into caves, oceans, forests at night, their minds fill with stories. The void forced humanity to confront that instinct on a cosmic scale. A void so large, so silent, so geometrically precise that it felt like a question posed by the universe. What do you fear most, the unknown, or the possibility that something is hidden behind it? This psychological dimension soon overlapped with a profound existential one. If the void was truly a scar, a bruise left behind by an event outside normal physics, then the universe itself carried trauma. Not metaphorical trauma, literal trauma, etched into its structure. Philosophers debated what it meant for a universe to have a history before humans, before stars, before atoms. Did the universe remember? Did it carry the memory of contact with another realm? And if so, did that memory change the nature of existence? More radical thinkers proposed that the void represented a limit, not just of science but of perception. They wondered if the void was a place the universe did not want observers to enter. A barrier between dimensions. A threshold between states of reality. A region where the rules lose their coherence. Their arguments weren't scientific, but they resonated deeply with the emotional weight the void carried. Sometimes what frightens us is not the data in front of us, but the feeling that the data is incomplete. And then came the interpretation that unsettled even the hardened scientists. What if the void was alive in a conceptual sense? Not alive like an organism but alive like a process, something dynamic, evolving, interacting. A kind of cosmic behavior. A region that suppresses signals, alters geometry, thins spacetime, and resists expansion. Philosophers wondered aloud whether the void could be a part of the universe's immune system, or a remnant of something that once passed through and left behind a hollow in its wake. As the debates intensified, one theme began to echo through both scientific and philosophical circles. The void was not passive. It was not merely empty. It was doing something. Acting. Influencing. And perhaps understanding the void required not just physics or mathematics, but a deeper reflection on the nature of reality itself. One philosopher summarized the unease perfectly: the void is not a place. It is a question. A question the universe asks every sentient mind: how much truth are you willing to see? As scientists mapped galaxies and philosophers mapped meaning, the void grew larger in significance. It became not just a physical anomaly, but a psychological abyss, reflecting humanity's deepest fears about creation, destruction, and the fragile limits of human understanding. And lurking behind every interpretation, every debate, every sleepless night was the same haunting thought: if this void is a mirror of our deepest fears and unanswered questions, then what exactly does it say about the universe that created it? Astronomers originally assumed the void was static, an ancient pocket of emptiness frozen in place, a silent remnant of some forgotten cosmic event. Voids by definition don't move. They don't behave. They don't act. They simply are passive hollows in the cosmic web. But as measurements became more precise, something quietly unnerving emerged. The void wasn't still. It wasn't calm. It wasn't inert. It was influencing things around it, subtly, gently, but undeniably. Galaxies near the boundary weren't behaving the way they should. Their velocities drifted, their trajectories bent ever so slightly, as if nudged by a whisper of force emanating from inside the darkness. It was a motion so faint that early surveys dismissed it as noise. But the deeper the analysis went, the clearer the pattern became. The galaxies were moving as though responding to something inside the void. Something hidden. Something pushing or pulling in delicate, almost rhythmic ways. No one wanted to believe it at first. Emptiness shouldn't exert influence. But the data told another story. The earliest clue came from galaxy cluster L452, positioned near the void's outer rim. Over decades of observations, its motion exhibited a subtle drift, an unexplained acceleration that didn't align with gravity from surrounding structures. It was as if gravity itself had been gently reoriented. The region wasn't just lacking mass, It was altering the motion of matter that passed too close to its boundary. This kind of influence required something with presence, with force, with behavior. Scientists ran models to see if dark energy fluctuations could explain the anomaly. The simulations failed. They tried dark matter asymmetries, failure again. They tried deep field gravitational lensing reconstructions, and found distortions that seemed to ripple across the void surface like waves rolling across a black ocean. These waves weren't violent. They weren't chaotic. But they moved. They moved. Like tremors inside a hollow structure. The void wasn't still. It quivered. Some researchers compared the motion to breathing. A near imperceptible expansion and contraction, as though the fabric of spacetime within the void pulsed, and this pulsing affected nearby galaxies. It was not a heartbeat, not a rhythm, but a slow oscillation occurring over unimaginable timescales. The void expanded in one region while contracting in another, like a sphere subtly shifting within an invisible container. The implications were staggering. Nothingness wasn't passive. It had dynamics. It had motion. It had agency? No one dared use that word aloud, but the unease it evoked clung to every discussion. As more teams studied the phenomenon, the void's behavior grew harder to dismiss. Its boundaries were not rigid. They fluctuated, slightly, irregularly but consistently. The walls of emptiness seemed to sway like curtains stirred by a breeze no one could feel. These movements didn't match gravitational interactions. They didn't match cosmic expansion. They didn't match any known physical mechanism. Instead, they resembled disturbances originating inside the void. But how could nothing disturb anything? The more scientists traced these motions, the more they noticed a disturbing pattern. The void seemed to react to large-scale cosmic events. When a distant cluster underwent a major merger, the void's boundary shifted, as though responding to the gravitational shockwave. When a supermassive black hole near its perimeter brightened due to rapid accretion, the void's temperature profile subtly changed. These correlations were faint, but the timing was too precise to ignore. It was as if the void were listening. More radical theorists suggested that the void might be part of an unseen network. Regions of weakened spacetime connected across vast distances like nodes in a larger topology. If so, the void's movements might reflect tension or stress traveling through this hidden structure. The universe might have internal dynamics we have never perceived, slow ripples through a deeper layer of reality. If spacetime has a skeleton, then the void might be where that skeleton shifts. But there was a more unsettling possibility. If the void was a scar left behind by an interuniversal collision, or by something passing through, then the motion might not be random at all. It might be fading echoes of that ancient event. A cosmic aftershock that never fully stabilized. A region of spacetime still trembling from the impact of another universe brushing against ours. In that interpretation, the void's movement wasn't current behavior, it was lingering trauma. Some theorists whispered an even more unnerving thought. The void might be slowly healing. The universe could be trying to fill in the wound, adjusting its geometry, reweaving its fabric. But something inside the void resisted that healing, creating a slow oscillation as the universe tried to correct an injury too deep, too foreign, too unnatural to mend. And then came the most frightening hypothesis of all. What if the void wasn't healing? What if it was growing? Data revealed that certain regions of the void had expanded slightly over the last few 100 million years, not by much but enough to raise alarms. The void's interior density was thinning even further, approaching levels that defied physics. It was as if the void were consuming structure, dissolving the scaffolding of spacetime itself. Not violently but quietly, an erosion of reality's foundation. If true, the void wasn't just moving. It was evolving. Scientists struggled with the psychological weight of this realization. A moving void suggested activity. Activity suggested processes. Processes suggested rules. Rules suggested purpose. And purpose implied intention, even if only in the most abstract, physical sense. The universe was never supposed to behave this way. The void's subtle motion challenged not just models, not just theory, but the fundamental assumption that the cosmos is stable, comprehensible, and complete. It forced humanity to confront a terrifying possibility, that we live in a universe with regions that behave like entities, not environments. A void that moves is not a void at all. It is an event, a phenomenon, a presence. And as scientists stared into that slow rhythmic shifting of nothingness, one question grew louder in their minds, whispered, denied, then whispered again: is the void responding to something, or is it waiting for something? From the moment humanity first mapped the cosmos, one pattern stood out above all others. The universe is not random. Its matter is arranged in vast webs, threads, knots, and voids, structures so enormous and intricate that they resemble biological or architectural designs more than chaotic explosions. As scientists zoomed out, past galaxies and clusters and superclusters, they saw the same pattern repeating. A cosmic lattice stretching across billions of light-years, like a massive, interconnected neural network. But nowhere did this hidden architecture become more mysterious, more haunting, than in the region surrounding the void. To understand the void, scientists first had to understand the structure it violated. The universe is woven from filaments of dark matter, gigantic, invisible strands that form the backbone of cosmic structure. Galaxies cling to these filaments the way dew clings to spider silk. Clusters gather at the nodes where multiple filaments intersect, forming bright islands of stars surrounded by deep oceans of darkness. These filaments create cosmic walls, vast sheets of galaxies forming the boundaries of enormous voids. Everything on the largest scale follows the same pattern: filaments, walls, nodes, emptiness. Chaos forming order. But the void we discovered didn't fit. While ordinary voids form from the natural ebb and flow of matter during cosmic expansion, this void existed like a disruption in the pattern, as if something pressed a thumb into the web and stretched it apart with unnatural precision. Its boundaries were sharper, cleaner, more defined than any cosmic structure should be. Filaments bent around it not organically, but as though forced to adapt to a foreign intrusion. It did not resemble a hole in the web. It resembled a design imposed onto the web. Researchers began layering data from galaxy surveys, dark matter maps, gravitational lensing, and cosmic background radiation. What they saw was unsettling. The region around the void displayed unusual symmetry. Filaments curved around it in arcs too smooth to be random. Dark matter density decreased in gradients too regular to be natural. Even the distribution of surrounding galaxies formed patterns reminiscent of ripples, like waves created by an object dropped into a cosmic pond. This was not simply empty space. This was structure. In some models, the void acted like a repulsive center, pushing matter outward in a pattern consistent with an old, powerful disturbance. In others, it resembled a pocket of weakened spacetime, a region where the universe's foundational energy fields dipped or collapsed. Still other models treated the void as the result of a massive, spherical interference pattern, as though something spherical once pressed into our universe and left a perfect indentation behind. The deeper scientists studied the architecture, the more bewildering it became. At certain wavelengths, the filaments around the void showed signs of distortion, almost like tension lines. The dark matter scaffolding near the boundary twisted slightly, as if stretched by a force not accounted for in standard cosmology. When simulated backward in time, these distortions converged on a single point, a moment early in cosmic history where the void's formation diverged dramatically from natural evolution. The architecture around the void wasn't just unusual, it was wrong. Wrong in the kind of way that implies violation. Something acted on the cosmic web. Something that wasn't gravitational collapse, quantum fluctuation, or dark energy expansion. The patterns hinted at directed influence, like the marks left behind when a hand presses into fabric, pulling threads and fibers into unnatural alignment. Philosophers called it intentional. Scientists called it anomalous. Mathematicians called it non-random. All three were correct. The most radical subset of researchers proposed that the structure around the void resembled interference patterns. Patterns seen when waves collide. If the cosmic web were a dynamic field, then the void might be the dampened center of a massive wave interference effect caused by something entering or exiting our universe. In this interpretation, the void wasn't created by the universe, it was created in the universe by something external. Others took a different approach, modeling the void as the absence around a collapsed higher-dimensional object. They imagined a colossal structure passing through the early universe, a hyperdimensional phenomenon that left behind a cavity in its wake, like a shadow cast by an object we cannot see. In these models, the void's shape was not just intentional, it was architectural. A structural deformation left behind by something powerful enough to warp spacetime on an unimaginable scale. But the most unsettling discovery came from studies of cosmic topology. When mapping the universe's large-scale structure, researchers found that the void's position was suspicious. It lay near a delicate juncture in the cosmic web, a region where multiple filaments connected in a rare, unusually balanced configuration. This was not a random place. This was a structural weak point. The universe, like any architectural structure, has points of strength and points of tension. Stress points. Vulnerabilities. And the void sat precisely where a structural vulnerability existed, like a door placed in a wall or a hinge on a gate. This realization sent shockwaves through both scientific and philosophical communities. If the cosmic web has architecture, and if the void sits on one of its stress points, then the void might not just be a scar. It might be a mechanism. A feature, not a flaw. A doorway carved into the universe's hidden structure. The implications were staggering. Was the universe designed with vulnerabilities? Was something capable of exploiting them? Did the void mark a point of entry, or a point of escape? Every new map, every new model, every new layer of data made the void look less like a natural anomaly and more like the remnant of a cosmic event that interacted with the universe's very blueprint. An event so enormous, so ancient, that it sculpted the architecture of the cosmos itself. And if the void was shaped by forces beyond our understanding, then it raises a single terrifying question. If the universe has hidden architecture, what else? What other structures, scars or openings, might we one day uncover? Because once you see the pattern, once you understand the cosmic web not as chaos but as design, you can never unsee it. And the void becomes not an absence, but the first hint of a much larger structure. One the universe has spent billions of years trying to keep out of sight. Humans have always feared emptiness. Not the gentle emptiness of a quiet room or a blank page, but the deep, devouring kind, the darkness behind an open door at night, the bottomless ocean below a sinking ship, the stillness of a cave where light refuses to live. Emptiness is more than a lack. It is an invitation for the mind to project its darkest possibilities. It is a canvas for fear. And as humanity stared into the cosmic void, that ancient instinct returned with staggering force. Because this emptiness was not metaphorical. It was real. A region so vast, so silent, so unnaturally perfect that even seasoned scientists felt their breath catch when they looked at it. Psychologists studying the responses of astronomers noticed something unusual. Those who spent long hours analyzing void data, staring at the maps, the simulations, the hollow contours, began describing an emotional shift. They felt a subtle dread. Not terror, not panic, but a quiet, lingering discomfort. A sense that the void wasn't just empty, it was watching. This was, of course, irrational. But the feeling was persistent. The void affected people the same way deep ocean trenches or forbidden caverns do. It awakened a primal fear rooted in our species long before we understood the stars. This fear made sense. Emptiness is a threat in nature. A silent forest means predators. A quiet night means danger. An empty horizon means something has driven life away. Our ancestors learned to fear places where nothing moved, nothing breathed, nothing lived. Such places were signs of death, famine, or lurking predators. And in the void, on a cosmic scale, humanity encountered the ultimate version of such a place. A silence so complete that it defied all assumptions about how the universe should behave. But the void triggered more than instinctual fear. It provoked philosophical dread. Emptiness raises uncomfortable questions. If something this vast can exist without matter, without energy, without structure, then what does that say about the universe? About creation? About meaning? The void forced humanity to confront the possibility that existence may not be filled with purpose or design. That on the grandest scales, reality allows for hollows so deep that they swallow entire regions of meaning. Scientists found themselves wrestling with emotional responses they were trained to suppress. The void was supposed to be data, not a psychological mirror. Yet researchers reported sleepless nights after viewing its structure. They described dreams of falling endlessly into a black sphere that grew larger the deeper they descended, a hunger without form or intention. Others dreamed of standing at the edge of a vast circular gulf in the sky, so enormous that it filled half the heavens, and feeling a pull, not physical but existential. And then came the most unsettling psychological phenomenon. The void made people feel small. Not the ordinary smallness one feels when looking at the Milky Way or contemplating cosmic time, but a crushing insignificance that bordered on despair. When confronted with the void, even the brightest minds experienced moments of existential collapse. They felt that the universe was not just vast but indifferent. Not just mysterious but actively silent. That humanity was not simply a small part of the cosmos, but irrelevant to its deeper story. Philosophers recognized this sensation immediately. They had felt it for centuries when contemplating the concept of the absolute void, the nothingness that predates existence. The void in space, they argued, triggered the same emotional reaction because it resembled that primordial nothing. It looked like the absence from which everything came. And if that absence still exists, untouched, unchanged, undisturbed, then maybe the universe isn't the stable structure we imagine. Maybe it is fragile. Maybe it is temporary. Some thinkers offered a different perspective. They argued that the void should not be feared but respected. That humans fear empty places because they are unfamiliar, not because they are dangerous. They suggested that the void was an opportunity, an invitation to explore deeper truths about the cosmos. Just as ancient explorers feared the ocean yet crossed it anyway, humanity must confront its fear of the cosmic abyss to discover what lies beyond. But even this hopeful view carried its own edge of dread. Because fear exists for a reason. Fear protects us. Fear warns us when we are approaching something we do not understand. And the void is the embodiment of the unknown. It is too perfect to be a natural emptiness, too symmetrical to be random, too silent to be simple. Feels like a boundary, a limit, a place we are not meant to enter. The psychological conflict became clear. Science pushes us toward the void. Instinct pulls us away from it. One physicist described the feeling perfectly: it's like walking toward a door you didn't know existed. And when you reach it, you realize the door is open. Fear of the empty is not weakness. It is wisdom encoded by evolution. And the void amplifies that wisdom to a cosmic scale. It whispers that some spaces should remain untouched. Some mysteries should remain unentered. Some truths should remain unspoken. Yet humanity cannot help itself. Curiosity is stronger than fear. Discovery stronger than caution. And perhaps the universe knows this. Perhaps that is why it hides its deepest secrets not behind barriers, but behind emptiness. Because emptiness dissuades all but the boldest minds. Still, one question haunts every psychologist, philosopher, and scientist who gazes into the void. Do we fear the void because it is empty, or because something might be waiting inside it? Fear of the empty is universal. But fear of what emptiness hides, that is what keeps humanity awake at night. From the moment scientists began tracing the history of the void, it became clear that its story reached far deeper into cosmic time than anyone expected. To understand the void, one could not begin with galaxies or clusters or the cosmic web. One had to journey back, to the first seconds after the Big Bang, when the universe was a seething, glowing ocean of particles, energy, and violent expansion. A time before stars, before matter, before atoms. A time when darkness had not yet been born. Yet somewhere within that blinding infancy, the seeds of the void appeared, seeds that suggested a history older than light itself. In the earliest moments, the universe was hot and uniform, expanding at unimaginable speed. Tiny quantum fluctuations, minute ripples in energy density, became the foundation upon which all future structure formed. Some of these ripples grew into galaxies, others into clusters, others still into cosmic voids. But none of these fluctuations could produce a void of the scale we now observe. The void was too large, too smooth, too precisely carved. Its characteristics did not match the early universe noise that inflation stretched across the cosmos. It looked like something else entirely, an imprint placed upon the universe before structure had even begun. To trace the void's origins, scientists examined ancient radiation, the cosmic microwave background, the universe's oldest light. Within that faint glow, streaked across the sky like the fingerprints of creation, they found a shadow, a cold depression. A region where the primordial plasma seemed thinner, quieter, almost hesitant. This cold imprint aligned perfectly with the void's location billions of years later, suggesting that the void was not a structure that formed, but a structure that survived. It was a relic, a fossil, a scar from the dawn of time. As cosmologists reconstructed the universe's evolution through simulations, the void's existence raised impossible questions. To create such a massive emptiness, a colossal force must have acted during the earliest fractions of a second, during an era where physics itself was malleable and undefined. This led some researchers to a chilling hypothesis: the void might predate cosmic inflation. If true, it would mean the void formed when the universe was still forming its identity, its rules, its laws, like a bruise appearing on soft clay before it hardened. In that early darkness, before light, before matter, before time existed as we know it, the void may have taken shape. To understand how this could occur, scientists analyzed the interplay of energy fields that existed during the universe's birth. The Higgs field, the inflaton field, quantum vacuum states. These forces competed chaotically, creating rapid expansions, contractions, and transitions. If one of these fields behaved differently in a localized region, it could have created a bubble or pocket where spacetime evolved out of sync with the rest of the universe. This pocket, stretched and magnified by inflation, could become the void. But if that were true, then the void represented something extraordinary, a region where the universe's rules did not fully take hold. A patch of proto-reality. A remnant from before the cosmic script was finalized. This idea unsettled even the most hardened cosmologists. If the void contained echoes of pre-time physics, then studying it could reveal chapters of existence never meant to survive, the raw chaos of creation itself. Other theorists proposed an even more dramatic possibility. What if the void was not created within our universe at all? What if it was the intrusion of another universe during the earliest phases of cosmic inflation? A collision so ancient that it predates spacetime as we understand it? In this scenario, the void was the cosmic equivalent of a dent formed when two realities brushed against each other while still embryonic. A glancing blow between universes long before matter condensed or galaxies formed. If so, the void might be older than everything inside our universe. Older than stars. Older than atoms. Older even than time. Philosophers seized upon this idea, arguing that if the void predates the universe's structure, then it might carry imprints of a pre-cosmic state, a time when existence had not yet differentiated into matter and energy. In their view, the void was not just an anomaly, it was a memory. A memory of what reality looked like before it became reality. They imagined the earliest darkness, not the absence of light but the absence of definition. A silent, formless realm where nothing had yet chosen to be something. In such a primordial environment, the void would be a window. A window into a time when the universe was still deciding what it would become. A window into the first darkness. Not darkness as we understand it, but the darkness of pure potential. The void, they argued, might be the universe's oldest museum piece, preserved across billions of years by cosmic expansion. As the simulations continued, one detail emerged again and again. The void seemed to resist the universe's growth. It expanded, yes, but not at the same rate as surrounding structures. It was as though the void were anchored to an older state of physics, a state frozen in time. A fossilized chunk of pre-modern reality embedded within our universe like a relic trapped in amber. This resistance suggested something extraordinary. The void might hold properties that do not exist anywhere else. Properties that belong to the first darkness, before the birth of particles, before the rise of symmetry, before the universe settled into its current form. If this interpretation was correct, then exploring the void, even conceptually, was akin to digging into the universe's childhood. A childhood filled with instability, violent transitions, and unimaginable forces. And if the void contains remnants of that era, then it might hold answers to the greatest cosmic mystery of all. What existed before the universe? Scientists, philosophers, and theorists all found themselves returning to the same haunting question. Did the void survive from a time before creation, or did it come from somewhere completely outside creation? In either case, the implication was clear. The void does not belong to the universe as we know it. It is a visitor from the earliest darkness, a fragment of a time that predates meaning, order, and structure. A fragment of a story we were never meant to read. By the time the void had shaken the foundations of cosmology, something strange began happening in the scientific community. Ideas that had once been dismissed, buried, laughed at, or quietly ignored, started resurfacing. They returned like ghosts, emerging from old papers, abandoned theories, rejected proposals, and late-night discussions that never made it into academic journals. These ideas weren't wrong, they were dangerous. Too bold. Too disruptive. Too untestable. And so, for years they had been pushed aside. But now, confronted with a void that defied every conventional law, researchers found themselves revisiting these forbidden theories, dusting off concepts that had been silenced not by evidence, but by fear of their implications. The void forced open a door that the scientific world had kept locked for decades. One of the first theories resurrected was the bubble collision hypothesis, originally proposed by a handful of physicists who believed our universe was one bubble in a foamy sea of universes. Their early work hinted that collisions between universes could leave behind massive imprints, scars across spacetime, just like the void. But the idea was too radical at the time. It implied that the Big Bang was not an isolated event, but part of an ongoing cosmic ecosystem. It implied that our universe was not unique. It implied that we were not alone. Fear of ridicule killed the idea before it had a chance to grow. Now the void breathed life back into it. Alongside it came the vacuum decay residue theory, once considered fringe. It proposed that regions of spacetime could temporarily fall into a lower energy state, creating pockets where reality behaved differently. These pockets, if stabilized, could expand, contract, or even leave behind cavities in the cosmic structure. But the idea terrified physicists. If true, it meant the universe could spontaneously collapse in a chain of destruction triggered by a single quantum fluctuation. No one wanted to explore a theory that implied reality itself was fragile. So it was quietly shelved. But the void behaved too much like such a pocket to ignore. Another ignored idea resurfaced from the early days of string theory, the brain interference model. It suggested that our universe was a three-dimensional membrane, a brain, floating in a higher-dimensional space. If two brains brushed together, even momentarily, they could create massive distortions, leaving behind hollows, scars, or regions of strange physics. But the theory was mathematically overwhelming, nearly impossible to test, and dismissed by many as overly complex. It faded from mainstream discussion. Yet the void, with its spherical precision and thin spacetime shell, resembled exactly the kind of imprint such an encounter might leave. Another forbidden idea emerged from an obscure corner of quantum gravity research, a concept so unsettling that even its authors hesitated to publish it. The spacetime erosion hypothesis suggested that certain regions of the universe could undergo structural decay, where spacetime becomes thin, weak, or unstable. This erosion could be triggered by exotic energy fields, ancient collisions, or phenomena outside known physics. It was rejected because it sounded too philosophical, bordering on metaphysics. Spacetime wasn't supposed to erode. It was supposed to be stable, eternal. But the void's thinning of dark matter, its gravitational softness, aligned disturbingly well with this idea. Then there were the theories scientists whispered about but never wrote down. Hypotheses that crossed the boundary between science and myth. Ideas like, what if the void is a region that the universe actively avoids? Or, what if something passed through our universe and the void is its footprint? Or even, what if the void isn't a natural formation but an artifact? These theories were dangerous because they implied intention, purpose, agency, concepts no cosmologist wanted to tangle with. But the void demanded that they be revisited. As more suppressed ideas resurfaced, a disturbing pattern emerged. Many of them fit the void better than mainstream models ever did. The void wasn't simply an astronomical anomaly. It was a challenge, a riddle the universe had been hiding in plain sight. And for the first time, scientists realized that the theories once deemed too strange were in fact the only ones capable of explaining what they were seeing. Yet even as these theories gained momentum, there were reasons they had been silenced in the first place. Many of them led to conclusions that terrified researchers. They suggested that the universe might not be stable, that reality might not be uniform, that ancient events might have left scars deeper than galaxies. They suggested that the universe had a history it kept hidden, a past filled with collisions, collapses, and interactions with realms that left behind no matter, only absence. Some theories went even further. One proposed that the void was not just a scar but a consequence, the dead remnant of something that once existed. A bubble of reversed entropy. A collapsed dimension. A pocket where time briefly flowed backward during cosmic infancy. These ideas were too abstract, too bizarre, too unimaginable to accept, so they were buried. But the void's silence forced them back into the light. Another theory, whispered in the halls of theoretical physics departments but almost never written, suggested that the void might be a sterile zone, an area the universe itself had quarantined. Like a scar wrapped in cosmic bandages, insulating the rest of reality from something dangerous, something unstable, something that should never have interacted with our universe in the first place. Scientists resisted this idea, not because it lacked logic but because it implied intention. A self-regulating universe. A cosmos that protected itself. But the void looked eerily like a quarantine zone. Then there was the most unsettling theory of all, the one that had been buried deeper than any other, the one once dismissed as pseudoscience despite coming from reputable physicists. The void may be a region where information goes missing. In a universe governed by information, such a region was unthinkable, impossible, forbidden. If information could vanish in one place, it could vanish anywhere. Reality could unravel. Yet the void erased signals, erased waves, erased structure, erased history. The void did not simply reflect mystery. It consumed answers. And the return of these forgotten theories forced researchers to confront the truth. Perhaps the void wasn't a puzzle to solve. Perhaps it was a warning. A cosmic scar the universe tried to hide. A silence it hoped would never be disturbed. A truth buried beneath billions of years of cosmic evolution. Theories were silenced for a reason. And now, as they resurfaced, the reason became terrifyingly clear. Some ideas aren't dangerous because they're wrong. They're dangerous because they might be right. As technology improved and telescopes sharpened their gaze, the region surrounding the void began to reveal a new kind of anomaly, one that was not made of emptiness or silence, but of faint, fragile signals whispering across the boundary between ordinary space and the abyss. These signals were not loud. They were not clear. They were not even consistent. But they existed. And their existence changed everything. For decades, the void had refused to speak. It swallowed radio waves, muted microwaves, distorted light, and reduced gravitational signatures to near nothing. It was a perfect absorber, an ocean of silence so profound that researchers began to treat it not as a passive region, but as a phenomenon. Yet as detection methods grew more sensitive, scientists began noticing tiny anomalies at the outermost edge of the void. They were subtle, so subtle that early computers dismissed them as noise. But the patterns kept returning. Weak pulses, stray oscillations, ripples so faint they seemed accidental. Except they weren't random. They clustered around certain regions of the void's boundary, areas where spacetime was thinned, stretched, or warped. These faint signals behaved like whispers leaking through a sealed wall, like distant voices filtered through layers of distortion. When the oscillations were converted into visual plots, scientists saw shapes, periodic spikes, irregular tremors, and strange rhythmic fluctuations that resembled interference patterns. No known cosmic process behaved like this. No galaxy, no star, no black hole emitted signals this faint or in these specific frequencies. It was as though the void itself had edges that murmured. The first group to take these patterns seriously was a research team specializing in gravitational anomalies. They noticed that the void's boundary seemed to vibrate ever so slightly, like the surface of a drum struck from the inside. These tremors were not gravitational waves, they lacked the signature. They were something else, a phenomenon that confused even experts in spacetime physics. The boundary behaved like a membrane under tension, occasionally quivering from internal shifts. But internal shifts of what? To investigate further, astronomers pointed extremely high-sensitivity receivers at the void. At first they detected nothing unusual. But when they amplified the data by factors previously considered reckless, faint signals emerged. Signals that grew stronger when the receivers were angled along certain tangential regions of the void. These signals were so delicate they seemed to dissolve into nothingness the moment they were observed. Yet the more scientists analyzed them, the more they found an unnerving consistency. They came from the edge of the void, not from within it. Something at the boundary was creating tiny disturbances, like fingerprints on glass. Some researchers compared the signals to oceanographers listening for echoes along the walls of deep underwater trenches. The deepest, darkest regions of the ocean generate peculiar noises, currents brushing against cavern walls, pressure shifts echoing through submerged stone. And in a similar way, the void's boundary seemed to generate low-level tremors, as though reacting to stresses within or responding to external cosmic events. In one particularly groundbreaking observation, a research station recorded a strange burst of oscillations coinciding with a distant galaxy cluster's gravitational shift. As two massive galaxies merged in a faraway region, the void's boundary flickered, as if the void felt the disturbance. This wasn't coincidence. The timing was too precise. It suggested a level of connectivity that defied explanation. Cosmologists began to argue fiercely about the implications. Some believed the void's edge was simply a transitional region, where spacetime stretched in unusual ways. Others believed the signals were relic echoes of whatever event created the void. Still others whispered a more unsettling possibility: perhaps the void was not silent at all. Perhaps it was communicating, but only in the faintest tremors, indistinguishable from noise unless one knew exactly how to listen. And then came the moment that changed everything. A refined sensor array captured a pattern, not a random tremor, not a cosmic echo, but a structured sequence of oscillations. It was brief, lasting just fractions of a second. But the signal had shape, rhythm, a curvature in its frequency that suggested internal order. Scientists examined the sequence under every known filter: radio, microwave, gamma, and gravitational. Nothing matched. The pattern wasn't natural. It wasn't chaotic. It was deliberate. Not intelligent in a human sense, but intentional in a physical one, like the sound of a pressure valve releasing or a cavity resonating in response to internal stress. In other words, something inside the void had shifted and the boundary responded. The team that detected the sequence refused to publish their results at first. They feared mockery. They feared controversy. But most of all, they feared the implications. Because if the void's boundary could shift in structured patterns, then the void was not dead. It was dynamic, active, alive in some physical sense. When the data eventually leaked, it sparked a storm across the scientific world. Was the void moving? Changing? Interacting? Theories erupted everywhere. Some claimed the signals were the remnants of ancient gravitational scars, echoes from the collision that formed the void. Others proposed that the void was thinning, its interior weakening as the universe expanded. But a growing number of theorists believed something far more dramatic. The void was not a corpse. It was a threshold. A threshold that reacted to stress. A threshold that murmured when pressure changed. A threshold that might open, or close, under the right conditions. The whispers from the void's edge became the most studied phenomena in modern cosmology. Teams around the world competed to record clearer data, but the signals remained elusive. They were like distant voices carried on wind, impossible to hold, impossible to repeat, but undeniably real. And as researchers stared at the faint oscillations dancing across their screens, one thought kept returning, unspoken but irresistible. Maybe the void is not empty. Maybe the void is not silent. Maybe the void is trying to say something. Or worse, maybe something on the other side is trying to speak. In the end, after centuries of measurements, debates, fear, data, and discovery, every thread pointed to one undeniable truth. The void was not just a place. It was a revelation, one that forced humanity to confront the deepest questions about existence, reality, and the unseen forces that shaped the cosmos long before life emerged on Earth. To understand the void was to understand the universe in a new light, not as a perfect machine, but as a story woven from scars, silences, collisions, and secrets. And as the final pieces of the mystery aligned, the void revealed something far more profound than emptiness. It revealed the nature of the universe itself. When scientists combined the gravitational data, the structural mapping, the faint oscillations, the cold spot imprint, and the hidden architecture of the cosmic web, a picture emerged, subtle at first, then overwhelming. The void was not an accident. Not a random fluctuation. Not a temporary anomaly. It was a remnant of an event so enormous, so fundamental, that it rewrote the boundaries of reality. It was a survivor from a time before galaxies, before atoms, before the universe solidified into the structure we see today. The void was, in its own silent way, a message across time. What it revealed was unsettling. The universe was not born clean. It was born wounded. Every theory that once lay buried, multiverse collisions, brain interference, vacuum pockets, pre-inflation fractures, now aligned into a single, coherent possibility. The early universe experienced something violent. Something external. Something that pressed against its forming structure and left behind a permanent scar. That scar expanded with the cosmos, stretched across billions of years, and became the void we now observe. And the faint signals at its edge, the trembling boundary, the thinning of space-time, all these were echoes of that ancient trauma. Humanity had always imagined the universe as a cradle of order. But the void revealed a different story. Order arose only after surviving chaos. The revelation forced philosophers and physicists alike to reconsider what creation meant. If the universe was shaped by forces beyond itself, forces from a realm we cannot perceive, then reality was more porous, more interconnected, more fragile than we ever imagined. The void taught us that our universe does not exist in isolation. It exists in a sea of possibilities, collisions, boundaries, and unknown neighbors. The implications were dizzying. If the void was evidence of an ancient collision, could more collisions come? Could universes interact again? Could something pass through? The more humanity understood, the more the void shifted from a threat to a teacher. It revealed that emptiness is not meaningless, it is a record. It revealed that silence is not absence, it is memory. It revealed that the universe carries scars, just like we do. And in those scars, truth resides. As the final analyses were completed, a poetic realization settled over the scientific world. The void was not a flaw in the cosmos. It was a reminder of where the cosmos came from. A reminder of the fragile balance that holds reality together. A reminder that the universe is not the smooth, eternal expanse we once believed, but a tapestry stitched together by forces that existed long before light. Some researchers proposed that the void might be a boundary between phases of reality, an ancient interface where one universe touched another. Others believed it was a relic of a collapsed dimension. A few dared to whisper that perhaps it was once a doorway, open only for a moment in the early universe, wide enough for realities to brush against each other before sealing shut. But the most profound interpretation came from those who viewed the void philosophically, that the universe tried to hide this place, not out of malice but out of fragility. Because revealing the void meant revealing the truth that the universe itself is not invincible. It is not eternal. It is not complete. It is still growing, still healing, still remembering. And the void is the place where those memories live. In the final scenes of this cosmic story, as the camera drifts into the dark hollow one last time, the viewer is left with a single realization: the void is not a hole in the universe. It is a window into what lies beyond our understanding, a silent archive of events older than time. The darkness is not empty. It is full of meaning, full of history, full of questions the universe never intended to answer. And as the final frame fades to black, one lingering thought remains, quiet, haunting, unavoidable. If the universe hid this truth for so long, what else is it still hiding? What other scars lie scattered across the cosmic web? What other thresholds wait in the dark, unseen, untouched, unentered? The void was the first, but it will not be the last. And whatever lies beyond that silence, the universe remembers. In the aftermath of the void's revelation, humanity found itself changed, not through catastrophe or contact, but through understanding. A shift had occurred, subtle yet irreversible, as if knowledge itself had pulled us over some invisible threshold. The universe no longer looked like a static expanse of stars. It looked like a living manuscript, each galaxy a sentence, each filament a paragraph, each void a redacted chapter the cosmos had tried to bury. And as humanity digested this truth, something else became clear. The universe had not finished speaking. There were other places, other anomalies, other shadows, where the familiar laws bent under pressures we still could not name. Researchers began to sift through old data with new eyes. Observations once dismissed as artifacts, noise, or coincidence suddenly looked meaningful. Strange distortions in the cosmic web. Temperature dips in unexpected regions. Unexplained alignments of galactic motion. These anomalies were subtle, far subtler than the Great Void, but they formed a constellation of clues, scattered across the sky like dim beacons pointing toward something enormous. And yet none of them matched the void. None had its silence. None had its symmetry. None had its history etched into the earliest light. The void was unique, a keystone in a puzzle too large for any one mind. But the other anomalies hinted that the void was not isolated. It was the loudest signal among whispers, the clearest tremor on a vast, trembling surface that stretched far beyond our observational horizon. This realization ignited a new urgency in the scientific community. A feeling that humanity stood at the edge of a revelation not about the past but the future. If the void was a scar left behind by an ancient event, an impact, a collision, an intrusion, then what if that event had consequences that echoed through the universe even now? What if the void was simply the first wound discovered because it was the largest, not because it was the last? As teams reanalyzed gravitational maps, they discovered peculiar threads of disrupted structure. Narrow lanes where galaxies seemed subtly bent out of alignment, as if pulled sideways by invisible currents. These currents did not originate from dark matter or cosmic expansion. They seemed to originate from beyond the void's region, as if pressure waves had rippled outward from the scar far earlier in cosmic history and were only now detectable. These distortions formed patterns, delicate, looping arcs that spiraled across superclusters like signatures carved into the fabric of space. Some researchers compared them to fault lines in planetary crusts. Others compared them to stress fractures in metal. A few compared them to interference patterns created when objects pass through a medium and leave trails behind. The idea was controversial but impossible to ignore. Something had moved through the universe once. Something massive. Something ancient. And the void was merely the deepest footprint it left. This triggered a philosophical shift. Humanity began to see the void not as an anomaly, but as a chapter marker, a boundary separating what we know from what remains hidden. If such a presence once passed through the universe, what became of it? Did it retreat into hidden dimensions? Was it destroyed in the collision? Or did it continue traveling across realities, leaving behind scars wherever its path intersected with spacetime? Some theorists dared to suggest that the faint oscillations at the void's boundary, the whispers we barely detected, were not simply echoes of the past, but signs of an enduring connection. A thinning. A weakening. A place where the membrane of reality remained stretched and sensitive, vulnerable to forces we cannot measure. If the void was a weak point, then perhaps other weak points existed. Perhaps the universe was filled with them, thin seams in its structure left behind by ancient encounters. And perhaps, under the right conditions, those seams might be disturbed again. This thought terrified even the boldest minds. It implied that the void was not simply a relic. It was a warning. A map. A marker indicating that our universe had neighbors. Neighbors with histories, trajectories, and consequences. Neighbors capable of shaping our reality with a touch. neighbors whose existence we could infer only from the wounds they left behind. But there was another interpretation growing quietly in scientific circles, one less catastrophic and more philosophical. Perhaps the void was not a sign of danger, but of inevitability. Perhaps universes collide the way tectonic plates collide, the way stars collide, the way ideas collide. Perhaps the void was not an exception, but a natural process in a larger system. A system that sees our universe not as a lone miracle, but as one thread in a tapestry woven from countless realities. This interpretation brought comfort to some. It suggested that the universe was not lonely, that existence was not a singular accident, that life emerged in a cosmos shaped by interactions so vast they leave lasting scars. It suggested that we were part of something larger, even if we could not see it directly. Yet even this hopeful view carried unease. Because if universes interact, then interactions can happen again. And so humanity stood at a crossroads, caught between awe and fear, between wonder and uncertainty. The void had peeled back one layer of reality, revealing just enough to unsettle but not enough to explain. It had shown us that the universe remembers its past, even when it hides it. It had shown us that reality is fragile, layered, and interconnected. It had shown us that scars exist even on cosmic scales. But the void had also done something else, something subtle, something profound. It changed the direction of human curiosity. We began no longer asking small questions about stars, planets, distances. We began asking the largest questions possible. Where does our universe sit within the greater structure? How many scars lie hidden beyond detection? What forces shaped the earliest moments of reality? And what might still be shaping it now? The void was the beginning of a new era in cosmic understanding. A doorway, not opened but noticed for the first time. A reminder that the universe is not finished, not settled, not silent. As humanity gazed into that colossal sphere of darkness, the truth became impossible to ignore. The void is not the story of nothing. It is the story of everything we do not yet understand. And somewhere, out there in the cold deep, beyond the thinning membrane of space-time, beyond the scars etched in the cosmic web, beyond the reach of our instruments and imagination, the next revelation waits. Silent, patient, watching, just like the void did. As the void's mystery settled into the collective consciousness of humanity, a final haunting realization began to take shape, one that no telescope, simulation, or theory had prepared us for. It arrived not through data but through perspective. Through the slow and dawning understanding that everything the void had shown us was not merely about what lay beyond, it was about us too. Because in staring into the universe's deepest wound, humanity had inadvertently seen its own reflection. We had always imagined ourselves as explorers of the cosmos, charting the unknown with tools of logic, curiosity, and bravery. But the void revealed something deeper, that we were children looking into a dark forest, convinced we understood its shapes, unaware of the seasons that came before us, unaware of the footprints buried beneath its soil, unaware of the ancient storms that shaped its landscape long before we learned to walk among the trees. The void changed that. It stripped away our illusions of cosmic certainty. It peeled back the comforting belief that existence is stable, familiar, predictable. It showed us the truth. The universe is ancient beyond comprehension, scarred beyond memory, and intertwined with forces that do not care whether we understand them. And yet, within that terrifying revelation, there was something profoundly beautiful. Because the void also showed us that we were capable of seeing beyond ourselves. Capable of recognizing the universe as something more than stars and distances. Capable of asking questions whose answers will outlive us. Capable of imagination powerful enough to reach across dimensions and touch the edges of realities beyond our own. In the years following the discovery, humanity's scientific institutions experienced a quiet transformation. Conflicts calmed. Rivalries softened. Researchers who once defended their theories with pride now shared data with humility. Because the void taught them that knowledge was not a possession, it was a responsibility. A fragile chain of understanding forged across generations. A chain the universe had dared us to extend link by link into the dark. New telescopes were designed, not just to capture light but to detect the faint tremors of spacetime itself. New detectors were built, not to amplify signals but to listen for silences. Teams of physicists, philosophers, and even artists gathered to interpret what those silences meant. Governments, once hesitant to fund deep space research, began to support international collaborations aimed at studying the void with a seriousness once reserved only for threats. Because now the void was not a threat. It was a teacher, and the greatest teacher humanity had ever encountered. But as our understanding deepened, so did the questions. If the void was a scar, what caused it? If it was a doorway, where did it lead? If it was a relic, what had come before it? If it was a boundary, what lay beyond the boundary line? Some theorists believed that the void marked the edges of our universe's infancy, a bruise left behind by a cosmic collision we could never hope to witness again. Others believed it marked the footprint of something passing through, a being, a structure, a phenomenon so vast that our universe barely registered its presence. Still others, more poetic than scientific, claimed the void was a region where the universe itself had questioned its own existence. A place where reality thinned under the pressure of possibility. But the most profound insight came from a simple observation. The void mattered because we could see it. It mattered because it existed inside a universe capable of witnessing it. It mattered because we were here, small, fragile, temporary, and yet somehow able to detect the fingerprints of events older than time. The void revealed the staggering contrast at the heart of existence. The universe is immense, but it is also observable. Its secrets are unfathomable, yet they leave traces. Its scars are ancient, yet we have evolved eyes capable of seeing them. And that fact alone made humanity realize something extraordinary. We are not insignificant. We are the witnesses of a story far larger than ourselves. We are the only known beings capable of looking at a cosmic wound and asking, what happened here? The universe does not tell its story willingly. It buries it in silence, in darkness, in distances so vast they swallow meaning. But through persistence, fear, curiosity, and wonder, humanity found ways to listen. Ways to interpret the clues hidden in voids, filaments, scars, and light. The void's revelation was not only scientific, it was existential. It reminded us that we are part of a universe still healing from ancient trauma. A universe still expanding from ancient collisions. A universe still echoing with the remnants of events that shaped everything we see, and everything we are. And perhaps the most humbling realization of all was this: the void is not the universe's greatest secret. It is simply the first one we were capable of uncovering. There may be others, hidden behind cosmic horizons, cloaked behind dark energy, folded into the higher dimensions our instruments cannot yet penetrate. There may be scars deeper than the void, boundaries sharper, silences older, doorways waiting for the next species brave enough, or reckless enough, to approach. For now, the void stands at the edge of human understanding like a vast, silent monument. To look upon it is to look upon the universe's oldest memory. To study it is to trace the lines of a story that includes us, but does not center around us. To fear it is natural. To seek it is inevitable. And as humanity continues its slow journey toward deeper knowledge, one truth remains as haunting as it is beautiful: the void is not empty. It is a reminder. A reminder that the universe is larger than our stories, older than our fears, stranger than our imagination, and more connected than we ever believed. One day, future civilizations may come closer to the void, closer than we ever dared. They may cross the threshold. They may enter the silence. They may discover what lies beyond. But for now, humanity stands on the brink of cosmic understanding, staring into a darkness that both shields and reveals. And in that final moment, the universe, through its deepest scar, whispers a message that echoes across every star, every atom, every breath. You were never meant to understand everything, but you were meant to try. And so we do.